Good morning, everybody. Welcome to CRE 21 lecture. I have the great pleasure of introducing my good friend, Guru Madhavan, who is the Norman Augustine Senior Scholar and Senior Director of Programs of the National Academy of Engineering, where he's also the founding director of the Forum on Complex Unifiable Systems program. He has served as the technical advisor to the US Department of Health and Human Services and the European Union Malaria Fund. Earlier, in the medical device industry, he has contributed to the research and development of surgical catheters for cardiac ablation and neuromuscular stimulator for improving blood circulation. A systems engineer by background, he received his MS and PhD in biomedical engineering and MBA from State University of New York that awarded him the Edward Weisband Distinguished Alumni Award for Public Service or Contribution to Public Affairs. His recent awards include ASME Henry Lawrence Gantt Medal for Business Leadership, AAA AAMI Lofman Grichbach Great Batch Award for Contribution to Health Technology, IEEE Norbert Weiner Award for Social and Professional Responsibility, IEEE Alfred Goldsmith Award for Outstanding Achievement in Engineering Communication, and IEEE USA Award for Distinguished Literary Contributions Furthering Public Understanding and the Advancement of Engineering Profession, and George McClure Citation of Honor for Engineering Leadership. He's a member of a lot of things, and he was elected fellow of IEEE, American Association of Advancement of Science, American Institute of Medical and Biological Engineering, ASME, American Society for Mechanical Engineering. He was former vice president of IEEE USA and founding member of the Global Young Academy. His books include nonfiction Applied Minds, How Engineers Think, that has been translated into many languages, and he has several other books. He's a prolific writer and a very good speaker who has given lectures all over the US and Europe. With that, I hand over the mic to Guru, and Guru, it's all yours.
So thank you so much, and greetings to everyone. I want to thank you for your time today. I want to engage with you on a crucial engineering subject that's obvious and overlooked, both in education as well as our broader career and civic priorities, to fundamentally reimagine engineering education, as this group aspires to do. Will involve us to think about the basic politics of recognition between innovation and maintenance, and how we choose to prioritize one act of engineering at the expense of another. One's dazzling, the other's dull. One concerns competition, the other relates to care. I also want to explore with you a thesis, perhaps to see how some aspects of showmanship can be fruitfully applied to boost the unsung acts of maintenance, and how we as engineers should responsibly strike the balance in how we present ourselves and our work. So let's start our journey in the New York City of mid-1800s. You're looking at a hand-colored lithograph from 1855. The magnificent city, you'll see, has no skyscrapers. The stunning structure in the front was called the Crystal Palace. Long before Times Square, the Crystal Palace was the shimmering attraction in the 13-acre Bryant Park in Midtown Manhattan. Poet Walt Whitman called it Earth's modern wonder. It was a centerpiece of the World's Fair that began in summer 1853. Over 1.25 million visitors came to the fair from dozens of countries and colonies. They paid 25 cents a ticket. They marveled at the iron and steel palace, quite a grand one. They were impressed by the trendy technologies of the time. A whaling gun boasted deep hunting of monsters. An automated tobacco roller cut and wound 18 cigars a minute. But the wonder that still resonates today was a May 1854 demonstration. It was by Elisha Graves Otis, a 42-year-old engineer who made bed frames and loved tinkering. He cleverly designed an elevator wagon that spring meshed with a ratchet. It created a passive automatic braking system. He didn't invent the elevator per se, but something perhaps far more crucial, the elevator safety brake. Until then, elevators were by and large used in granaries and factories, but the traditional hoists had safety problems. They didn't sell. It wasn't because people didn't need elevators, but elevators often catastrophically broke down in warehouses, sometimes killing the passengers. Otis realized that his design was simple and superior, but lacked showmanship. The World's Fair was his moment. In his suit and hat, Otis mounted a wooden platform notched by notched guide rails here, as you can see. His assistant, way up here, then hoisted the platform some 50 feet from the ground. It grabbed the crowd's attention. Then dramatically, using an axe in his hand, you can see here, he cut off the suspension cable holding the platform. The crowd just gasped in shock. It was an act of lunacy or suicide, really, for Otis standing on the platform. However, the platform stopped with a jerk, just a couple feet lower, arresting the free fall. All safe, Otis reassured, all safe. Otis's performance was one of the first tech demos in a modern sense, with its forgotten yet famous words that gave birth to skyscrapers. In 1857, the first commercial elevator was installed in a New York City department store on Broadway for $300, rising 40 feet per minute. By 1870s, there were 2,000 Otis elevators in service. Then in 1889, you can see the installation of Otis elevators in my backyard here, the Washington Monument. It took 12 minutes to reach the top. The same year, the Eiffel Tower opened. Otis installed 2 hydraulic elevators with double-deck design, holding 50-seated passengers. It traveled at 400 feet per minute. Here was a legitimate innovation. Without it, it's impossible to imagine urban life. But Otis's crucial safety innovation that launched the modern vertical city was enabled by now legendary stunt. From Thomas Edison's stage flare to Steve Jobs' turtleneck theatrics, the modern demo culture builds on symbolism, spotlight, and special effects, in which pomp is the essence of persuasion. Consider the rousing, even immortal words of President Kennedy in 1962. You're very familiar with it. The showmanship in his words was apparent, and it got us to the moon. But showmanship has to relay some meaning, especially when a technology or service or even public policy has not found a place in our lives. Now, the notion of moonshots has become so common in Silicon Valley, global tech firms, health policy speak, and even in government agencies, not particularly known for any innovation. The word, after all, can inspire us to attempt the impossible. Look at the Google Ngram viewer here, which shows how word use has increased or decreased in the past since 1800. There's a bump in the use of the word moonshot right after Kennedy's speech, and it rockets further up in recent years. Even look at the generic word innovation and its increasing presence in our lives and careers. How about disruptive innovation? Exactly like in break things, move fast, you ever heard that? A word that was once common to consulting firms, venture capital firms, and Silicon Valley tech firms is now a subject in middle schools. It's risen very swiftly in use. A very similar trend can be seen with the use of the word social innovation. And even the broader concept of design thinking itself, that fundamentally shares a spirit of innovation, also shows a stiff, steady escalation. These trends have led to something materially different from the genuine act of innovation. Now we have relentless innovation speak. We are all beneficiaries of genuine innovation. We need more of that, like Otis's safety brake. But innovation speak is not innovation. It is sales pitch surpassing substance. But of course, I'm here today to talk about the unsung partner of innovation. In fact, the enabler of innovation, one that's less sexy and more vexy. What Kennedy called the other things. Good engineers and engineering firms know well that maintenance is both life and larger than life. And it needs a bit of showmanship to attract attention to gain its proper place in our civic and career priorities. Look at how the word trends over time. We can see a robust decline in the use of maintenance as a concept and as a sensibility. In early 2021, we saw a jarring contrast of an engineering triumph and tragedy. One was the innovation relating to the Mars rover landing, and the other was a maintenance misfortune with Texas blackout. National Academy of Engineering president, my boss, John Anderson, and I wrote about what we call the Mars rover and the blackout problem. Why are we willing to invest in putting a rover on Mars, but not in the mundane responsibility of keeping the nation's infrastructure in good shape? Our question wasn't really novel. In fact, it was posed by scholar Richard Nelson in the 1970s. Nelson asked, why is civilization adept at moon landing while failing to successfully address poverty and other social ills? We are yet to resolve this conundrum. As maintainers nurse the grids, pipes, and sewer lines back to service in Texas, one thing became abundantly clear. We cannot afford on-again, off-again seriousness about the care of critical civic infrastructure. Colossal costs are engendered in choosing to mitigate what could have been forestalled. We have seen this too, of course. All of us went through this in COVID-19, a wicked tangle of the many equivalent rovers and blackouts. If you deepen this argument a bit, it's kind of worse. Engineers too have gotten to the habit of liking to be known and celebrated and promoted as innovators, as if it's a major rebranding exercise for professional identity. In reality, a vast fraction of engineers, at least 70% of them, maintain and oversee existing systems. They don't run around disrupting things. They thankfully avoid disruption. Similarly, 70% of the federal budget spending, which is a decade ago, and with the recent investments, have all gone to new and shiny construction, not operations and maintenance. In engineering, value is created in many different ways. Now, this is a 2019 paper that identifies 14 such pathways here. Of course, innovation, research, and development are crucial instruments in engineering here, but only a minority of engineers are engaged in these performances. Similarly, product differentiation, efficiency improvements, you can see through this performance forecast, the due diligence work, standards, testing, checking, design reviews, and technical collaboration, and importantly, minimizing environmental harm and preventing unsafe behavior, for example. These considerations led me to feature a separate chapter on maintenance in my next nonfiction called Wicked Problems that'll be out in March 2024. I'd like to pick out two segments from it and preview them for you, each covering different aspects of maintenance. Call the first example The Tale of Speed Kings. The reference here is to steam navigation of the early 1800s that replaced horse-pulled transport. During mid-1800s, as cotton, molasses, and whiskey trade boomed, steamship services increased. The captains, though, were addicted to speed. They stoked the boilers and shut off the safety valves. As steam pressures increased, they turbocharged the ships. Naturally, it was a source of thrill, but also some tragedies. In 1838, Congress passed legislation for steamboat safety standards, boiler inspections, and firefighting equipment. The law held ship owners and operators liable for murder, neglect, and malfeasance, with years of hard labor as punishment. Yet, the measure was weak to prevent further accidents. In the following decades, just as the interstate commerce grew, so did the number of steamboat explosions. Between 1807 and 1853, steamer explosions killed over 7,000 people, competing with the fatalities from hurricanes and floods. And defective or ill-serviced boilers were a chief reason. Then followed the worst disaster in the US maritime history. It happened just days after Abraham Lincoln's assassination in 1865. The 2-year-old steamship Sultana departed New Orleans in the early darkness of April 27th, 1865. You'll see the 4-storied, 260-foot liner journeyed to St. Louis, Missouri, with 300 people on board, and it hauled hens, horses, mules, sugar casks, and coal bins. It made a stop in Vicksburg, Mississippi, a Confederate military post. Nearly 2,000 Union soldiers, released from rebel prisons, boarded the ship. Sultana was now carrying 5 times the maximum load. 3 boilers blew up a few miles north of Memphis, Tennessee, shredding the slides and blistering the boat. The mishap killed 1,800 lives, surpassing the fatalities of the Titanic in 1912. Hundreds more drowned in Mississippi as Sultana burned. The boat's chief engineer later recalled that inadequate repair of the boilers led to the explosion. Technical fixes can often help solve hard maintenance problems, such as pressure vessel explosions. So can policy statutes, as in creating new proof testing standards, banning competitive racing, setting carriage limits, and so forth. This was one of the earliest case studies in federal government setting safety laws that has spilled over into much of modern regulation. It has also become one of the earliest conflicts about the so-called government meddling with industry affairs that affect public welfare. A lesson that's become clearer and clearer over time is a very simple one. Maintenance is deeply interlocked with safety. Now, with digital monitoring, we can achieve extraordinarily high levels of system availability and reliability. A couple of years ago, the German power networks reached a reliability level of 99.9997, with an average outage duration of under 10 minutes in a year. Broadband services have 99.999% availability. That is 5 nines. In some areas, it's 9 nines. Private companies, even those proudly marketing themselves as disruptors, spend up to 60% of their operational expenditures, or OPEX, on maintenance. These maintenance platforms are what made our transition to the online world readily possible during the pandemic. In an op-ed shortly after the COVID outburst, I argued that people take these systems engineering achievements for granted, especially the complex internet, mobile, and gas networks. We also saw how well-maintained production lines led to the brisk conversion of lab notebook formulas to a wholly new class of COVID-19 vaccines, and the dramatic scale-up of disease testing and manufacture of protective gear, all in months rather than years. We also saw when a Facebook shutdown occurred for several hours, the diagnosis was fundamentally related to maintenance. Yet, Netflix and Facebook brand themselves as disruptive innovators while deeply relying on maintenance. Or this past January, we saw how FAA grounded to a halt because of a systems failure that affected thousands of flights across the United States. This, again, according to a senior official, quote, has been a result of a mistake that occurred during routine scheduled systems maintenance. Or this past February, and I was a victim of this, we saw how Lufthansa services were crippled because of a severed cable that knocked systems offline, stranding thousands of travelers at Frankfurt Airport and elsewhere. You get the point. Which takes us straight into the second story. Call it the tale of the four sublimes, which focuses on the enterprise-level issues of maintenance. We all know of and are victims of delays common with infrastructure. The construction of ports, airports, hospitals, highways, stadiums, cargo logistics, even tax and census infrastructure consume far more time and resources than anticipated. These mega projects, or $1 billion or more, are getting bigger and longer with seemingly no end in sight. I'll give you an example from the UK. The West Coast Main Line was first created in the 1830s. It's a busy 400-mile corridor between London and Glasgow, with links to Birmingham, Manchester, Liverpool, and Edinburgh, serving a mix of commuter and freight rails. The major maintenance project was initiated in 1998. The goal was to improve tracks, the station, the tunnels, the signals, and the bridge spans. Two British firms, Railtrack and Virgin Rail Group, worked on the essential upgrade to introduce new high-speed tilting trains, the Pendolino trains. However, lacking concrete goals and an implementation plan, the program quickly went off track. The costs exploded, the schedule was off kilter, the specialty engineering groups didn't talk to one another, derailing teamwork. In 2002, the final project expenditure soared from an anticipated 2.5 billion pounds to an absurd 14.5 billion pounds. By then, Railtrack had delivered only 1/6 of the project scope. Railtrack faced bankruptcy, pulled out. The public sector intervened. A nonprofit took over project management. Network Rail was created and followed through requirements with a renewed focus on outcomes, monitoring, and accountability. More delays and cost overruns were unacceptable. In 2007, nearly a decade later, Practical Requirements Management turned the project around, successfully delivering on the first two phases. The results showed increased train speed and frequency, better punctuality, decreased journey times. But the excess cost of £6 billion from previous efforts was avoidable. The key point here is, in many live, large-scale projects, designers and installers don't necessarily talk to the maintainers at the outset. The Bayonne Bridge is another example I've written about. Engineered by Otmar Ammann with the architect Cass Gilbert, the bridge opened over Kilvan Coal Strait in November 1931. It was the world's longest through-arch bridge, at the time connecting New Jersey and Staten Island in New York. The Steel Crescent, 325 feet tall, 85 feet wide, became an emblem of elegance and economy, though less famous than its twin in Sydney. In the early 2010s, the widening of the Panama Canal created a problem for the Bayonne Bridge. A new generation of post-Panamax mega ships couldn't fit under the Bayonne Bridge's 151-foot vertical clearance. The Port Authority of New York and New Jersey had three options. First, remove this bridge and replace it with a new tunnel, and that would cost them $3 billion over 15 years. Second, they could retain the original arch and rebuild it with the cables stayed model, also expensive, but would have resulted in an odd-looking bridge. The third option was deemed the best and the most complicated. And you'll see, install a new road deck closer to the arch's apex. It would compromise the bridge's elegance, but create the necessary 215-foot vertical clearance. Now, raising the roadway on a bridge while keeping it open to traffic was an extraordinary engineering challenge. Someone compared it to conducting open heart surgery on a running patient. Building a bridge within a bridge also required safe staging of transit and crane operations. Plus, the project needed to minimize disruption to residential life and local ecosystem. The price tag for the elevation was $1.3 billion. Adjusted for inflation, it was 6 times higher than the original cost of building the bridge. Comparatively, in the 1930s, Amman had few restrictions. There were no seismic requirements, no concerns about infringing on residential areas, no environmental reviews. The bridge was delivered months ahead of schedule and under budget. By contrast, in 2009, the impact studies required to raise a roadway involved consulting with over 300 organizations, 50 Native American tribes. The resulting 5,000-page report cost over $2 million to complete. The report revealed that the Kilvan Col is a possible breeding location for about 6 dozen bird species, including the endangered peregrine falcon. Then, of course, the classic issues of NIMBY, not in my backyard, when people understandably oppose any project they don't want near their neighborhood. And some have real issues, right? Like toxic waste dump, casinos, homeless shelters, etc. And then there's banana engineering. Build absolutely nothing anywhere near anything, where there's wholesale opposition to any engineering project that's big, from shopping malls, stadiums, and golf courses. The Bayonne Bridge and the West Coast Main Line example that I discussed, their re-engineering illustrates something common to all projects involving infrastructure maintenance. I call them the grind challenges. Unlike the grand challenges that transfix communities with big, bold targets that push the frontiers of achievement, grind challenges are the myriad interlocking tasks that keep our highly engineered world functioning. They involve testing, inspection, standards, compliance, quality work, care work, all the nuances of negotiating to move load-bearing bureaucracies. Only few people, beside the workers who regularly wrestle with the details, are actually aware of them. Despite their low profile, grind challenges are tremendously important. They're defined not by their blue sky idealism, but by how well they accommodate nearly impossible constraints on and in the ground. Indeed, 90% of all mega projects have cost and schedule overruns, and this is from the work of Ben Fluberg. In real cost terms, you can see Suez Canal was 19% overrun, Sydney Opera House 14% extra, in New York State, the Verrazano Narrows Bridge was also engineered by Amman, 280%. The Boston Big Dig, for example, was over 200%. Oftentimes, and this is notable with big bang infrastructure packages, including the $1 trillion+ passed in the United States in recent months, one has to see what Fluberg calls as the 4 sublimes. The first is technological, which provides the excitement for engineers in pushing the envelope for what's possible. The longest, the tallest, the fastest type of projects, not necessarily the cheapest. The second is political, which provides the rapture politicians want from building monuments to themselves, so to speak, or for their causes, and from the visibility that these projects hold that can generate votes. The third is economic sublime, that provides delight to businesses, trade unions, and they make lots of money and jobs of mega projects. And contractors, consultants, bankers, investors, landowners, lawyers, developers, you name it. The fourth is aesthetic, which provides the pleasure that designers and communities seek from a good design, from like something very large that is iconic and beautiful. Let's say the view of the Golden Gate Bridge in California from your backyard, for example. The core of maintenance, care, repair, refurbishment, renewal can get hijacked by these sublimes. Tellingly, the very epitome of the grand challenge, the literal moonshot, was undergirded by so many interlocking grinds. The Apollo program, as you know, required contributions of more than 300,000 people, 2,000 contractors, 200 universities. To support this collaboration, NASA managers adopted military systems management techniques with a significant focus on clean room protocols and safety critical maintenance checks, the nitty-gritty details, that is. Europe's space agency, we don't talk much about them, they took an opposite approach. starting with an existing missile searching for a mission, as historian Stephen Johnson has written. Lack of attention to quality and safety details and the pursuit of parochial interests doomed the European effort while the US one succeeded. As Johnson points out, many of the solutions for the technical problems of rocketry turned out to be purely social and organizational. In other words, reaching what Buzz Aldrin called Moon's magnificent desolation first required a heroic commitment to mastering the magnificently mundane. In deploying moonshots as a metaphor and motivation, though, we must first acknowledge that many of the things our lives rely on aren't moonshots. Today's large projects go beyond buildings. They can be Joint Strike Fighter aircraft program, James Webb Space Telescope, wind farms, the National Ignition Facility, even large container ships, passenger cruise ships, military submarines. Each initiative comes with risks and uncertainties. We can manage them well only if we are strong in our fundamentals and conduct more responsible forms of engineering. As my colleagues and I note in our new paper out a few weeks ago, infrastructure of all kinds are nearing the end of their useful life and or beyond it, and demands beyond the original expectations are being placed on them. At the same time, with consequences of climate change and historic new infrastructure investments, the many large projects essential to public welfare must be completed reliably, successfully, economically, equitably, and promptly. And of course, emphasizing maintenance, project management, and studying historical case studies will be essential starting points, if not key framing points. But you see, engineering tends to valorize the lofty ideals of grand projects, but it is in the daily grind that the deeper pact between engineering and society plays out. Recognizing and rewarding those who manage the grind challenges is not at all a priority of today's incentive systems. Still, such responsibility should be at the very heart of sharpening equity considerations through engineering. A grind challenges sensibility can provide a more mature vision for conceiving and communicating engineering. What is engineering? What should it be? How do the practices work and who do they benefit? Not everything in engineering or life is exciting or needs to be made so. Little maintenance misfortunes may ultimately put a stop to legitimate big picture innovation. Why, after all, build a system if there's no ethic to maintain it well? Maintenance isn't a static process. It builds on change, and just like innovation, it fuels change. Innovators often claim to make history, but maintainers start from history and sustain the critical continuities of history. There can be no useful innovation without a vast, invisible infrastructure of maintenance activity that keeps our civilization running. I hope to have demonstrated that maintenance is where proper social accountability for the consequences of our work resides, and where we can find an accurate and grounded view of engineering. Perhaps this is how we may begin to understand the fundamental politics of recognition in engineering. We live in a time when the dazzling prominence of innovation overshadows the subtler, kinder, and attentive acts that characterize maintenance. This, I offer, leads to the collapse of everyday expectations. Very few subjects are as relevant and also neglected as care and maintenance, both fulfilling acts for our careers, corporations, and culture. Indeed, maintenance, we all know, over a system's life cycle may consume more than it took to make a new system. Of course, why repair a dishwasher when you can buy a new one for half the cost? But the result is often a catastrophe avoided. Engineers are full of such half jokes. Today's innovations are tomorrow's vulnerabilities, as you see. Without maintenance, of course, failures flourish. And we need some showmanship to articulate the value of maintenance, which takes us back to where we started. Elisha Graves Otis never thought he'd become a showman at the Crystal Palace. It was P.T. Barnum's idea, the famed entertainer, who thought showmanship was about getting into good graces of people. Otis got $100 from P.T. Barnum for the stunt. There was no need for an elevator pitch. Thank you.
Anyway, thank you for a lovely lecture. And I think the importance of emphasizing the importance of maintenance. And as we know today, you're talking about catastrophes and infrastructure. The recent rains and cyclone in Chennai is a very good example of poor maintenance and poor upgrading of the facilities and ignoring a large amount of the social infrastructure that maintains it. And you see the catastrophe that we have seen in the last few days or last month in Chennai. I think your talk has come at the appropriate time for our audience in India and elsewhere as well. I won't start with a question, but I would open it up for questions. Please, anybody, Shyam, if you want to start, please go ahead.
Sure. Thank you, Guru. It's an excellent talk on a superbly important topic, which I have wondered ever since my engineering topic. In the factory where I was trained, maintenance shop was called MTS. And that was kind of the most important and skilled work needed there, but lowest status, because the showmanship was missing, as you rightly pointed out. I just want to say a couple of things here. One, I think maintenance issues maintenance gets often neglected in organizations because either the budget for maintenance is not provided, or in public organizations, the budget is misappropriated or transferred to other projects where the decision makers, politicians, civil servants can make a claim. I made a new road, but I maintained a road is not a public, you don't win public acclaim. So budgetary issues are very important. And when you read military history all over the world, we all learn about the valor with which people on cavalry or infantry fight. But a very large number of battles, I would say majority of battles, are won and lost by cutting off supply lines or extended supply lines, which is exactly a maintenance issue. And finally, I wanted to mention, if you have not already seen, you might be interested in Jill Lepore's article in the New Yorker some 10 or 15 years ago, which was a famous takedown of Christensen's disruption principle, where innovation was the name of the game. And Jill Lepore shows how weak the foundations of that whole program was, and it almost came down after that. So my point is, innovation has acquired such a, as you pointed out at the outset, such a pizzazz with in public domain and in engineering, that maintenance counts as boring but essential. Let me stop here. Thank you.
No, thank you. deeply resonate with your points. I have nothing extra to add because I'm in complete agreement with every word that you have just said. I mean, let's face it, maintenance is a chore. I mean, none of us really like to do trash every day, but we have to do. That's, I think, part of this personal duty, civic duty, and so forth. But not appreciating it, as much, because I think those are civilization enabling, enhancing activities. And I think if we are serious about this, and if we talk about this as the more important duties than things that come and go in front of us, these are the ones that sustain us across civilizations. And we have seen even some of the earliest origins. And this is where I think maintenance and innovation hand in hand, to the point of even giving as an original vision for civic engineering. And that goes back to the Indus Valley engineering. But it was way before. I mean, how could you envision a system as advanced as that before, I mean, centuries before zero was invented? So this was kind of a non-numerical capability to understand a society's needs that's underpinned by maintenance. And the entire sanitation system that then evolved from it, or maybe as a sequence. I was recently in Italy, and of course, everyone is standing in the line outside the Vatican and the Pantheon and whatnot. I was hanging out by myself at one of the oldest sewer systems still working there. And I was just by myself and a few homeless people nearby, the Cloaca Maxima, 2,300 years old, still working. And the basic design has informed New York City's sanitation system. So it kind of gives you a perspective about how one goes about constructing systems for glory in this case. I think the sewer systems were a precondition for the successes the Roman Empire experienced in a way, and maybe lack of focusing on maintenance maybe led to their fall. I don't know. I'm just hypothesizing here, mainly because to prove a point that we somehow get carried away with the things that dazzle us rather than the dull ones.
If I may just add one small point here, that perhaps de-emphasis on maintenance might be encouraged in many systems where performance of the system in its early years after its creation, first few years or 10, 15 years, the deterioration in performance without maintenance may hardly be noticeable in a new system. So the budgets for maintenance get siphoned away elsewhere. And by the time then those things become obvious, the budgets are not there anymore.
Any more questions, Sudhir? You want to jump in? No, that
our reflections are welcome.
Our
reflections are welcome too, because as you know, I post a lot of questions myself, so I'd welcome reflections. And
I just want to, I can't resist. I want to say that I usually tell my engineering students success is a failure waiting to happen. So,
Good.
So Sudhir, go ahead.
Yeah. So one question I have is, from your perspective, how do you think one can make maintenance interesting?
How do you make maintenance interesting? So, and I think that I think a lot of educators in this group might have something to weigh upon here. Since when did we start emphasizing innovation? At least is a question, and I think I tracked it back to Kennedy's point, at least, and how influential it was, at least in the United States' discourse. But I think we need to think about when we got into this habit of consciously integrating perhaps the most vital act of engineering, when most of the engineers are involved in operations and maintenance, as I've talked about this, is as a question to wonder. I don't know if it was a conscious choice, whatever, cultural, funding, political, whatever choice that was. why we became that is a basic question that I'm struggling with. And I think it takes us back to how we assign prestige to the work in the different kinds, plural, kinds of engineering we do in society. And that's a question of interest to me right now, and that's informing some pieces that I'm working on.
Look at the software maintenance and software development. We have a similar challenge in terms of how much of the budget should be divided between the maintenance versus development. And the outsourcing strategies are also driven by some of these things. So, but what I have noticed is not all companies follow the same pattern of outsourcing. So, for example, one of the largest Canadian bank versus one of the largest US bank. What we have seen is the Canadian bank choose to keep maintenance in-house and outsource the development because they believe keeping their systems reliable is very critical from a compliance point of view and meeting their customer service. Whereas the American bank believe that their people are more capable of driving innovation, right? And therefore they can outsource all the legacy stuff. This is a very contrasting perspective. So one of the arguments I probably can add to this is this probably more cultural? Because you will also see something similar in the quality circles movement in Japan and other places where operational excellence and focus on operations, bringing about small improvements within this, that is more ingrained in that kind of environment, right? So is it more cultural?
I think it, as someone originally from India, I believe that, let's say, I think maintenance is recommended, perhaps implicit, even at the scriptural level. So during a previous visit to India, I happened to go to the temple in Sirgari in Tamil Nadu, and that was getting an upgrade, and they were having the renovation projects done at ultra speed because I think it was a matter of the community collecting the money to do the necessary thing. Even if you go back to the origins of maintenance from Indian cultural standpoint, the concept of Jirnodhara, the ritual renovation, every 12 years, a temple has to be upgraded, and similar practices can be found in Buddhist temples in Japan. I think if you look at how our engineering purely went into service of the local economy and the local community was through temples, and to perhaps even advance a political vision of kings and the local community leaders and so forth. So viewed in that way, I think maintenance went hand in hand, if not was a precondition to establish and sustain a community. So it was a form of social capital rather than financial capital. And I think that goes back to even some of the cultural changes, and there are probably many more case studies like this, how one bank in one country chooses to outsource what's more less critical or more critical, and how these countries view those actions is interesting. And I think it is, and I talked about the electric network reliability, at least with the German power networks and so forth. And those are explicitly stated goals. And even in the medical device industry where I used to work, or most notably, we all have experienced this in the aviation industry. Just waiting for a plane to take off, you just have to pass a few maintenance checks here. I think those are extremely vivid scenarios, especially in safety-intensive industries. They are critical. But in most others areas, and I wonder sometimes why we don't discuss this in most engineering curriculums about this. So I think we have perhaps relegated maintenance to the respective specialties and see what needs to be done. Mining industry also has significant maintenance one, and I talked about some examples in navigation earlier on in the shipping industry and so forth. So people who do this work know the innate value of it, but the people who talk about it seem to present it very differently, and that's where I see this jarring contrast between the branding exercise that engineers and technologists have gotten themselves into, a rebranding exercise rather. It's always cool to be known as an innovator. I mean, who wants to be a bridge retrofitter? Bridge builder gets more fame in society, of course, compared to the other aspects that we're all in agreement here. Something is off, and I think we need to refocus our attentions there.
Other questions from others? Please jump in. If not, I have a question. See, one of the mythologies in my mind is that there is no innovation in maintenance. This is a very big problem because there is innovation in maintenance.
Right.
Deep in, actually, the innovations in maintenance are often deeper than the original innovation. Because you are identifying not only failures, but you're also identifying potential failures and anticipating failures and trying to find ways to deal with it, right?
Correct.
So, I mean, have spent a lot of time in Netherlands. I was thinking about when you are talking about maintenance. Here is a society which will drown, literally, if their dikes and canals are not maintained, right? So there is that social consciousness of that we need, in order to survive, we have to maintain ourselves, and we have to maintain the infrastructure that needs to be in shape so that we all can have a decent life, right? I mean, that's why I brought up the Chennai example. It's a combination of poor maintenance, poor design, all of those things, and arbitrary ways of building housing in different places where you shouldn't. And I also will point to the example in Bangalore of the last big flood in which things were literally underwater. And to me, Kempegowda was a brilliant urban designer. And with all our fantastic degrees, we went around cutting all the lakes from each other in Bangalore. Well, and then draining the lakes and put housing there. So I mean, you think about the fact that in history, in our own Indian history, there are very good examples of design, maintenance, and sustenance, because Bangalore couldn't have become what it was in the days of Kempegowda without these lakes and interconnections as a prosperous community. So it's that infrastructure and the maintenance of the infrastructure that sustained it for 200 years. And here we come with modern ideas of, we're going to call them lakes, we're going to make them something else, and destroy, set the seeds of destruction of ourselves by not maintaining. I think your point, and Shyam and Sudhir, I think, also reinforced it. We have to teach students that maintenance is a place of generation of new ideas, new ways of getting to where you want to get to, and not just some boring job that you are doing every day.
So this is very interesting. Let me tack on to an earlier point I was making to Sudhir, and then get to your vital expression here. Even at least in the Hindu tradition, I mean, this is enshrined even at the highest level of the Trinity, Brahma, Vishnu, and Shiva. I mean, like, you got the God for creation, God for maintenance, basically Vishnu, and then God for destruction. And that ensures this kind of a cyclical process. So I think, say similarly in Judaism, the concept of tikkun olam, which is a conscious repair of the world we live in, conscious repair. And similar to ideas exist in Japan and China. So I think the concept of maintenance being a cultural consciousness or duty is well established. We just somehow have systematically de-emphasized it over time as it pertains to engineering and technology and economy and public policy. To add to your point here, and to Sudhir's relevant question here, how do you make maintenance exciting? And I think maintenance besides the showmanship argument, which I think the whole Silicon Valley culture is just enraptured in tech demo cultures and so forth. So I think that was where I was going with mine. But maintenance, to make it less of a chore, less of a dread, less of a drudgery, I think we need to bring in more innovative concepts to maintenance as well. And of course, digital upkeep and routine monitoring is going to help us with that. A Boeing aircraft going, I mean, collects how many terabytes of data just going between New York and London, and how many more flights operate? I mean, is it 1 million flights a day? I don't know what the numbers are right now. So we have enormous data sets going straight into the cloud. And I think those could help us. This is where I think a more relevant and a more practical and a more grounded application of AI could be helpful here. Because what do we do with that, rather than just saying that that AI is going to do X, Y, and Z? Because I think if we ground it to make maintenance modalities, mechanisms a bit more innovative, I think it's to our advantage here, rather than focusing only on innovation and excluding maintenance from the debate.
I know I'm a computer person, but still, while these huge collection of data and analysis are good, I also fear that the basic notion of maintenance as
Correct.
something which is fundamentally in your blood and bones. Because what if all these sensors fail? What if all these things fail? What do we have is our brain, right? And I think we have to be very careful in this smart madness that we could actually dig another hole. Like I said earlier, a success is a failure waiting to happen. This might be a failure waiting to happen at some point.
Correct. I even wonder when sometimes I see claims being explicitly or implicitly made saying that this next-gen technology is going to completely relieve you from any maintenance pressures. It's going to basically maintenance-free technologies, basically. Makes me wonder, I mean, if enough studies have been done on that, or if we are carefully engaged with those marketing concepts and so forth. So I view them with skepticism.
Any other? Yeah, go ahead, Shyam, please.
I have a slightly another different point of view here. I think the fundamental economic problem of maintenance is what we call opportunity costs. If Otis or whoever had not done that innovation, if somebody does not design the new building, build the new machine, build the new software, then it would not happen. And people can see the contribution of the quote innovator, because absence innovator, that internet, that computer, that machinery, that railway, that bridge, that road will not exist. Let's go to maintenance. Does the public see what would have happened if maintenance did not take place? Well, if you do the maintenance right, the accidents and failures will not occur. And people will not see what would have happened if that effort and money and attention was not devoted to maintenance. So the effect of maintenance, as is the case with all opportunity costs in economics, is invisible. If maintenance is properly done, its benefits are largely invisible, except to the experts like people who are on this call. The consequences of innovation, a new design, new building, so on, are visible. And I think that's a fundamental difference and the challenge.
Yeah,
mystery.
you articulate that very well, and I agree with it. I think an analog that exists is the kind of how the worlds of medicine, especially surgical care, acute care, have specialized themselves far enough from, let's say, nursing and public health, which is relatively kind of looking at intergenerational issues and looking for multiple years or preventing a pandemic, a next pandemic. I mean, that's largely in the realm of public health now, and often it is underinvested in. And we all know, I mean, the infrastructure is pretty fragile. We have learned about it just the past few years, and yet we don't seem to have the seriousness to invest in strengthening the critical infrastructure there. It ties back to the opportunity cost of it. It's always, I think, more recognized and recognizable as an activity if you invent something or clone a new sequence that has a widespread application compared to expecting behavior change or focusing on nutrition and other just daily health maintenance activities and of things. So there's something about that, while we know has long-lasting consequences, both if attended and not attended. And I think that's where I think how I'm hearing your message here as I'm articulating this point.
Yeah, but I don't have a solution. I still have to think seriously about what to do about it.
Yeah, that's exactly why I'm focusing on these matters, and I'm trying to engage at the highest levels to present these notions. I was fortunate to be involved in the G20 discussions earlier this year, and I think I brought up whenever the focus was exclusively on innovation or novelty and newness, which is welcome, of course. Who doesn't want it, right? But not to neglect the other things that make them possible. So I've tried to do my best.
Thank you.
Thank you very much, Guru, for spending the time with us. And given that you're not only writing books and also have a full-time job.
Yeah, I have a budget meeting in 20 minutes. So.
So it was a pleasure having you. Thank you very much. And
thanks for allowing me to rehearse these ideas here. And I will be speaking more about it when my book comes out. And but I think this is a group that with whom I was comfortable sharing these provocations, so to speak.
You are welcome to come back anytime and talk about the various aspects of engineering you continuously explore.
And by the way, let me promote it because my next book contains Sub's work. I'm featuring his work focused on the trash problem in Bangalore. And the work that his nonprofit did. So he's part of the book. So I would love to talk about that as well.
Okay, thank you so much for adding that. We look forward to future lectures from you as well.
All right, thank you. Whenever I have a vague dose of confusion, I'll be here.
Okay, thank you.
Bye-bye. Have a good one.
Bye.
Bye-bye.